Hello, sir.
Hello, Bhavana, I'm audible.
Yes, sir.
So, yesterday, did we completed the vector product? Bhavana, yesterday in the class, we completed with the vector product or we were left with some small topics?
So we didn't completed the vector product.
Just a moment. Okay. So, we can just complete the vector product today. Basically, whatever part was left. I'll just check first. Okay, yeah, I think some small part is.
You
Okay.
just said about IJK.
Yeah, I know. I know. Yeah, I shared my screen. Let me know if you can see this.
I can see, sir.
So look, we were discussing about the vector product. What is a vector product? You are given your two random vectors in a plane. Okay. When we are doing a cross product or vector product, our first task is multiplying the vectors which are at the 90-degree direction. So we can see they are not even in the 90 degrees. What I will do, I will just let any vector as it is. I will go to another vector and take its component which is at the 90 degree. So let's say this is a vector, this is b vector, and I have to get a cross b. Okay. What I will do, I will ask this b, who's your component when I make like when I'm going to resolve this. So he will say, um, okay, let's resolve b with along with you. Okay, a directions. So because by resolving this with respect to this, I will be getting another direction as at the 90-degree of it. Okay, and I have a data. This is theta, so I will call this as b of sine theta, b of, and this is a as it is. Okay, so now we can simply say that I can multiply it. I went and I multiplied it. This is what I have got the magnitude of product. Okay, magnitude. Still one part is left, that is direction. How I'm going to get the direction? If I say this is a single plane where all these things happen, the direction, okay, the final direction of this will be coming out somewhere at the top. Maybe this. Okay. So, this was your a of b of sine theta. This is b of sine theta. So this whole thing comes out as your direction of vector. Okay. So you can write this as unit vector. Okay. So this comes out unit vector. Clear? How you are going to get the direction? Um, Direction in a plane can be figured out using right hand palm rule, you can say palm rule. Okay, this is the rule you can use, or either finger rule you can say. Using this simple idea, your middle finger will be pointing towards another vector. This finger will be pointing towards the first finger, first direction, and your thumb will be pointing towards the direction. Okay, that's the thing basically. Here,
Yes.
alright. Okay, so basically, I can simply say that index finger pointing to first vector, middle finger pointing to other vector, pointing to direction of final vector, point to direction of final vector. Okay? That is called. Okay, and yeah, all of them are supposed to be kept at 90 degrees, which each other. All of them are 90 degrees to each other. Clear? This was a basic discussion. Then we moved and said A cross B can is also, you can see it is written as AB of sine theta, right? And it has n. What is the A? This magnitude of it? You can simply say the magnitude of it will come out as, look, when I do the magnitude, what is the task? I have to just do for the I have to think for the vector quantities, right? You can see this is just a magnitude, so we can keep as it is. And we know this is a unit vector, and the magnitude of a unit vector is unit itself. So what we have got, A cross B is equals to AB of sine theta. Clear? This is one thing. Now another part is, yes, if you have to calculate theta between angle, you can simply go and say I have A cross B, and I will divide this thing, the magnitude, by AB. Got it? In dot product, we say A dot B because this directly comes up as a magnitude, okay, and we don't have to carry in that case. So this AB of sine theta, so it was cos theta actually, not sine theta, cos of theta. So this comes out as cos of theta A dot B, which comes up as AB. Okay, this was the thing, and we know how to calculate this, right? But we are not yet aware how to calculate this part. We have a formula that I can get the value of this in this way, but still I don't know how to calculate it right now. Okay? For now, I really don't have any idea. So let's go further and look for I curve. In dot product, I said I dot I and then so on, so on, so on. That like I dot I comes out I. Okay, it comes out as one and so on. Okay. Here the things are a bit different. This is I. This is no, that is basically that was J, the I, and the third is K. Okay. So here what happens is I told you all the we have to look for the directions which are perpendicular. So I can simply say A cross J. Let's do it for first. What is I cross J? If you see carefully, you just take your right hand and start putting your thumbs like this. Okay. So when you just make your hand in an orientation where your index finger is in this way. Wait, index is in this. That's what it says. Middle finger is in this way because this is my second vector. Then your thumb will be pointing towards this direction. Okay, it will be resulting you K. J cross K will result you I, and the K is not right. I can simply say K cross I will be resulting you J. It follows the cycle of I, J, k. It follows a cycle. If you just turn up your cycle, the answer is going to be negative. Is that clear, Bhavna? Till here?
Yes, sir.
Okay. If I do I cross I, j cross j, what will be the answer in that case?
One.
Look at this again. Take a minute and let me know fast. It's not what you're thinking of.
Okay, zero.
Yeah, it's a zero, not one. Okay, because we are
Okay.
not doing the dot product. When I
Yes.
say cross product, it means I am looking for the directions which are magnitudes which are perpendicular. This is I itself, this is I itself. What is the component of it? Let's say I am doing the component. Angle is zero. I will say one direction is whatever the I of cos theta here, and here it is I of sine theta. So I can simply say the theta is zero. It means I don't have any what is that? Okay, if you solve it, sine zero is zero. It means I don't have any magnitude in the vertical direction in any house. So I can simply say that. Okay, you can simply say I dot I of sine theta, and sine theta is zero. So that comes out as zero. Clear? So that's the way you can go with it. Yeah, so
Okay.
fine. Okay, let's see. Okay, we are done with the most important parts. Let me know any doubt if you have till here. Any doubt till here? Bhavna, any kind of doubt till this point?
No, sir.
Okay. Okay, so some properties we will discuss. Properties of vector cross product. Vector product, cross product. So what are the properties? The first property is this is anti-associative. Dot product is associative. This is anti-associative. What does this mean? You can do A cross B, but it is not equals to B cross A. Okay. When you equate it, there will be a negative sign as direction changes. Direction get reversed. Okay. Because A cross B and B cross C is making will get you the same value of it basically. Mm, yeah. The magnitude it will get you the same, but direction will get reversed. Okay, is that clear?
Mm. Yes, sir.
Okay, another way is distributive property. So it's a it follows a distribution. What this mean? That A cross B plus C. So it can be written as A cross B plus A cross C. But yeah, here you can't do reverse. Like if you are doing A cross A B plus B, you can't so like do like A cross B and C cross A. Okay. In general mathematics, we used to do like 4 is given as 3 plus 2, so we could write it as 4 into 3 plus 2 into
Yeah.
4. Okay. Because we don't have to care about the directions here. Here the magnitude you are going to get the same, but direction get reversed if you do this. Okay. So you have to
Okay.
make care of it. Okay. Alright, so the next one is associative. Can we be associative? Yeah, we can do. So you can simply say that A cross B, not actually A plus basically A plus B, and this is cross is C plus D. Okay, I think so that is associative. Right, yeah, it should be anti-commutative. What I am writing that is associative. It was commutative. Anti-commutative. This is associative. Okay, you can associate it with associative. Means you can just multiply this in an order. So A, this is the cross, you can simply say cross of C, A cross of B plus, because there's an addition of it, so you can simply go and say B cross of C plus B cross of B. Okay, this is an associative. We are done with all the properties. You can also say if two vectors are parallel, are parallel, then parallel or anti-parallel, then cross product is zero. Mean to say A cross B, it comes out as AB of sine theta. Theta is zero if parallel. Theta is 180 degree if anti-parallel. Sine theta is equals to, okay, sine 0 degree is equals to sine of 180 degree. When all these values are equals to zero, so you can simply say whatever you did, your answer is going to be zero. Clear? I hope. Okay. So let's come up to the main part. How you can actually multiply these numbers. So you are given a. You are have to do a cross b. Okay. So assume I have a over here, and I can simply say that this is given as ax b. I'll call it as ax, ay, and aj in the k direction, in j direction, plus in I direction. This is it. Similarly, I have a b vector which is written as b of x, b of y plus b of z. That is so. This is what the vector is already of, and you have to do a cross b. We have just studied which is a property that is associative. It means you can associate them. All right, let's see. So a is written as ax plus ay plus a of z and k. Okay. Before going to this, can you just let me know the value of a dot b? In this particular case, I'll give you the value also. Assume this is 2, 3, minus 1, 3, 4, minus. Can you tell me the value of a dot b?
So the first one, 6.
First one?
6.
No, I
It's
just want a,
X.
I just want the full value. And why is x? Why 6x? Why x is there? Look, this is not a into x. Okay, this is not a into x. I am just representing a variable of x. Okay, because you can see I can't represent a, right? I have to represent by a, so I'm saying a in the x magnitude, a in the y magnitude, a in the z. Okay. This is just a variable to represent. Okay, it's not like a multiply x, a to the power x, or something like that. These are some representation. So get me the value of a dot b finally. Then I'll move to the a plus b.
19.
Okay, 12. Now, yeah, it is 19. Okay, it's 19. So that's fine. It's 19. You can simply, you have to do I, you just go and multiply I with I, j with j, k with k, you get the answer. But let's see, will it be the same in case of cross or not? So here after remove. So this comes out as a of y. No, what is x? B of x, right? I plus b of y I j plus b of z k. Now again, first idea, just take this, multiply with each other. So the first line I'll be writing for the AX, okay, and let's go with BX. So you can see I am doing I cross I because this is a
Sir,
magnetic
but I
incident.
cross I is zero, right?
Yeah, exactly, it is 0. So I'll put it 0, okay, plus I AX and BY. Okay, simply do because this is the magnitude. The main part is I into J. So what is I into J? Okay, I'll just make here a circle. Basically, I will create a cycle over here. We'll look into this. I'm doing I cross J. Yeah, it's a valid cycle. And if I do this, what I'm supposed to get? K. Clear?
K.
Okay. And the last AX, BZ, that is I cross K. Okay. So if you see here, I cross A, I don't have any cycle. I have K cross I, but I am doing I cross A. So I can simply say, if I'm going this way, I
Minus J.
I'm supposed to get J, but I'm supposed to get minus. Okay. So it will get just reverse, and I will remove this, and I will put it minus of J. Okay. All right. Let's start for the this. I'll add a plus. Okay, let's start here. I will add a plus sign because I'm starting with this. What is that? AY. Go with BX. What you're doing? J cross I. Again a reverse, so you will put minus. Clear? Plus AY with BY. AY, BY. Both are J cross J. That is 0. Plus here A of Y, B of Z maybe. Yeah, that is B of Z. What you are doing? I, no, this is J, right? This is you are doing I cross K. So this will result to I. Okay, you are doing J cross K. So J cross A results to I. So that is the thing. Now, last A of Z, Bx. What you are doing? K cross I. What is that? K cross I. Again, you can see K cross I will result to minus. Clear? Wait a second. K cross I is supposed to result to what?
J.
It's a complete cycle. Okay? It's not a reverse. This will result in J plus A of Z with By. By was I think J. Yeah, this is K. This is J. So you are doing K cross J. You have a cycle as J cross K, but you are doing opposite. So this will result you the opposite answer. That is minus of this minus of I. Clear?
Yes.
And the last is AZ, BZ, K cross K comes out 0. Now you can see all the diagonals. If you could remember in A dot B, only diagonals were left, right? And here we don't have diagonals, just we are removing the diagonals. Can I say this? If you could remember in the dot product when I was doing AX, BX, I dot I. This was left as 1.
Yes.
The rest all the rest out of these 9 values, all these 6 values get 0 in case of dot product. But here if you see in case of your cross product, these are the values which are left, all these diagonals gone to 0. Okay, so I can simply go and collect all I together, J together, K together. So let's start with the I. So I can say I have this as I, A Y B Z. Okay, one more thing, let's go in a sequence. Look, I have to put for I, right? I'm looking for I coordinate. Can I say this? What are the other two dimensions? One is y, one is z. Can I say this?
Yes.
Okay, so let's do simply do for the first vector multiply the y component. For the second vector, like okay, from the second vector multiply by the z component. Subtract with the reverse of it. Mean to say a of z, b of y. Let's go and check whether it is correct or not. I have I component with ay, bz. Okay. Another is this az, by. Is it correct? It is okay.
Yes.
For j, start with minus j. Okay, start with minus j. Now do the rest part. I am at the j right now. Don't say even after putting minus j. Don't say that you are starting with minus j. Just say start from j. So what you are starting, you can say you are starting with j. You had x, y, k component, right? You had three component. Right now you have chosen this one. So what you are left with x. You can simply say that A of x, b of a, b of z minus a of what is that? Yeah, b of x, a of z. This is what you can see. And let's go whether it is correct or not. So this is j component. I'll go for the j. So you can see you have a j as azbx. So this is azbx because look, there's a negative. So when you multiply this one, you are going to get is azbx. Okay. And another part is maybe here axbz. So axbz here is negative, but here it is positive. So when you multiply this negative, you are going to get it positive. Is that clear? Look at this problem. The reason of this because it is in really the part is reverse of what we are getting from here. Okay? So that's why we have to put a negative over there. Look at this and let me know if you're clear with this or not. Till here, if you're clear with this or not, let me know first. Then we'll move to the next. Hello, Bhavna. Am I audible? No.
Yes, sir.
Okay. Yeah. So, are you clear with the part what we are doing to till now?
Yes, sir.
Okay. So, what will be the last value? Just don't look at the top. I'm writing for the key. So, can you tell me what should be I have what I should write here? Try to figure it out. Like, look, every time you won't be able to make 9 blocks, right? When I give you to make cross of something, you should know some direct
Yeah.
sequence. Okay, this multiply this. Okay, I am getting the value. That you should know. That's what I'm saying. So just try to calculate this one. I think you can do it.
Okay.
Okay. So what is the for the k? Just tell me. Look at this sequence. Okay, what you have left and what you are choosing right now, and go in a particular sequence. And for the minus, you have to just reverse it. The sequence. Okay. Okay. Look for the k you are looking for. So you have chosen this one. What you are left with x and y. You have to go with the sequence. So a of x, b of y minus. Just make the reverse. A of y and b of x. Let's come and see for the k. For k in the negative, I have ay bx. Ay bx in the negative. Ax by in the positive. Yeah, it is correct. I can say this is my a cross. Clear, Bhavna?
Okay.
Okay.
Yes, sir.
Now assume if I give you the value directly, let's say I am saying this is 3 of I plus 4 of j minus plus 1k. This is what b is equal to I plus 2j minus 5k. And I give you, I said, give me the A cross. You have an option, you just go and do multiply one by one, one by one, one by one. You know how many times you have to. You have to do it 9 times. If you're smart enough, you will ignore the diagonal part and you will say, I want to do this with this one because I know it is coming out of zero. So I will simply ignore this part. When I'm at here, I'll be going with these two. When I'm here, I will go to these two. When I'm here, I will only go with these two. Okay, I want to go for the diagonal ones. All right, so still you have 6 operations to do. And then after these 6 operations, you have to merge them equally or take them accordingly. Okay? Another way is you can simply say that start with I. You know I need I component, right? You have 3 directions x, y, and z. What I did here, I will again explain the same way here. Okay, you are calculating for the I. Go in a sequence y and z. So you know for the first vector you have to take the y component, that is 4, multiply with the z component of the second vector, that is minus. And in the second case, just reverse it. If you have taken 4 and 5, now you have to take 2. No, now you have to just multiply, like reverse the thing. So what you are going to get this and this. So subtract it with 2 into 1. Is this part clear or not? Let me know. Okay, take a minute of pause. Even you can see I have formula here. A of y, that is this part. B of z, this is part. A of z, this part. d of y this part. That comes me, that gives me the ith component. Can you see this? Look at this and let me know the answer. Is that clear or not?
Yes, sir.
Clear, right? Then I can simply go for the, let's make it from here. I need j, and I told you for j, put a minus at the start. Now you have to start from computing. What is the next part? Okay, Bhavna, tell me what I should write for the minus j.
3 of minus 5.
3 of,
Minus 5.
okay, 3 and minus 5, right? Okay, 3 into minus 5. After that,
2 of 1.
which of what?
2 and 1.
2y, 2 and 1?
Okay, 1 and 1. 1 and 1.
That is, this is 1 and 1. So minus 1 and 1. You know there's a negative, okay? Plus the key at last. What you can do, simply ignore the rest part. You can say because I'm at the key, I want to look at, I won't even look at this, I will ignore this part, that I will ignore that it even exists here. What I will do, 3 into 2 6, minus 4 into 1, got the answer. So this is minus 20 and 2 minus 22 I, plus this is minus 15 minus 1 minus 16, no negative was there, so it comes out as total of 16. 16 of G, 2 of K. This is your vector. Okay, it's kind of easier method. If you practice a lot, you are getting the same in a less time. Okay, you won't even take 10 seconds to do this. This part is calculation. Like if you have got some higher values or fractional values, then it makes your time in calculation. But this step will not take much time. If you practice a lot, 10 seconds more than enough to do this. Okay.
Okay, sir.
And what we did here is as exactly as the determinant method. We have something called a determinant method. Okay, there what we used to do. First, we calculate for I, then J for K. Okay, I'll just explain it in very fast manner. A cross B. Again, I will take the same upper parameters like A, Z, and so on, so on. In that, what we used to do in determinant method, we keep I, J, and K component all together. For example, AX, AB, AY, AZ, BX, BY, BZ. Okay, for J component, because we see in general what happens, the determinant is a different thing. It is not just for the this thing. We have just taken a look from there. Okay, in in case of, yeah. So when we're taking determinant, we just have to choose any one row or any column. Although for sake of easy and for just teaching the vectors part, you can say that I'm taking this vector, but you can do the determinant by taking any, this column also you can take, this column, whatever column you are going to take, whatever what row you are going to choose, the answer is going to be same. Okay? This is the beauty of the determinant, but we have to choose for the, we are doing in the vector, so I can simply, I want to go in that detail of the determinant. I will simply go and say I'm choosing this vector, okay, because I need I, J, and K component. Okay. If you choose any other vector, you have to rearrange in some way so that you can get I, J, and K. Rearrangement will be there. Okay. So here you have simply I, J, and K. So what you can say, write I. For J, you have to put negative. What, that's why I told you whatever I have given you in this way. This is a direct determinant method instead of open method. Now what it is,
Okay, sir.
when you are at the I, ignore that you ever had I. Okay, and basically when you are choosing this vector, this value, you have
So,
to ignore
is
this.
this method mandatory? I think
No,
I'll be
it's not
getting
mandatory.
confused. I think.
It's not mandatory. Okay, it's not
Okay.
mandatory. You can solve it. Like again, it's a very easy. When you are at
The
I, just
method
ignore
which you have given is like it's easy.
this one.
Yeah.
Yeah, like it's an easy basically. This method is a derived part of determinant itself. Okay, but what
Okay.
happens is
Okay.
you don't have to make table and all. Simply you can say you have x, you have y, you have z. If you are x,
Okay.
take the y and z. Okay, when you are at y, just take z is negative basically, and do forget that you ever had y. Just do for x and y. When you are here, you can simply do for x and y. Okay, is that clear?
Okay, sir.
Alright. So I don't think I should go for the determinant, right? Because
Yes, sir.
like if you're right for the CBSE, then you should not, because they can give you, they can ask you just give me the cross product using determinant method. So, all right. So this is just an easy part. You can just make a table like this, and when you solve this thing, now this is itself a second step of the determinant. Okay.
Okay,
When you
sir.
make table and then you come up to this way, this is the second step. And now you can see that you have skipped the whole table part. You don't have to understand the table, you can simply do this if you can understand the pattern.
Okay,
Okay,
sir.
understood? Any doubt?
No, sir.
All right, so by this I'll end the session. I have to take another class also just now. Okay.
Oh, okay, sir.
All right, so look, we are done with the chapter, I can say now, mostly. So you can start solving problems. Do you have any book or something? Bhavna, yesterday I think I shared you one vectors PPT, right? Pro worksheet.
Yes, sir. I'll start doing that.
Yeah, okay. I forgot that I sent you. So you can start
E-
solving that. Okay, it contains a lot of problems from a subjective, objective, every kind of problem is there. So you can solve from them. Okay.
Okay, sir.
All right. So in next class, I will take a doubt if you have from that worksheet. Okay.
Okay, sir.
All right. So that's all for the today's class. I'll end the session by now.
Okay, sir.
So,